Hey everybody, Brian Laborde with Phase 3 of my Cockpit Refurbish, which is the panel lift kit. Because of the complexity and the amount of work in it, I didn't want to make the video too long, just to break it into more logical pieces. This first video is going to be more about what I'm trying to accomplish and the CAD work and design that went into it. And then the second video should be a little bit shorter and just showing the assembly to an extent and the final finished product. If you're more interested in just jumping to the answer and seeing the final, I'll put a link above that would go to that video, and also I'll put links in the description for the prior videos in case you want to back up with those. This is my 20. It's a ASW-20 Model A built in 78. And just as a level set, this is what my cockpit looked like shortly after I acquired the aircraft. It needed a lot of work, apparently, and I did a lot to it, flew it for years, not quite where I wanted it, but it was functional, and I finally this year decided to get into it and do some drastic improvements. And I will put the links to the videos in the description, and I think I might be put it above, but this is the new panel. And it's much better. It is the layout, the functionality, everything is fantastic. But the one thing that it did not have, and I've always wanted, was the lifting capability, having a lift kit. I looked into purchasing the standard lift kit that you can buy that attaches to the canopy strut mechanism, and really wasn't happy with that concept. For a couple reasons, and I'll talk about them in the video, but primarily the amount of wiring and changes with the plumbing that I would have to make with the tubes, etc., because of the height that it would lift was just not very appetizing. There's also a couple safety reasons why I didn't like it, and just didn't want my panel to weigh my canopy down and have to worry about getting a different lift mechanism for the canopy system as a whole. So being an engineer and looking at the problem, I decided to, well, let's see if I can design something myself, and really embarked on what turned out to be quite an arduous journey. I think I started this back in, I want to say July of 24, and here we are in January of 25, and I'm just finally getting the lift kit installed. So the solution really is a combination of a couple things. One, the software capabilities as well as the 3D printing capabilities really gave me some options that I didn't know existed and didn't know I had before. This is Fusion 360. It is an incredibly powerful package that I had just came across when I was looking at doing the lift kit, and found it's free for non-commercial use, and the restrictions that are on it for the free version really are, very few and don't really mean anything to me, since I'm not using it for something that's more complex. But most of the power, in fact, all of the power that's in the system is there. The functionality that is restricted is more about, how you get to certain things, etc. And really didn't mean anything to me for as far as restricting me to use it. But incredibly powerful system that I'll try not to make this video about the Fusion 360. I could do an entire series on it, but there's so many videos about the Fusion 360. If you guys really want to see something, I can try and do it, but there's so much on it. Just search YouTube and you'll find a million videos on how to use it. If you're doing any kind of design work, I strongly recommend Fusion 360. So first thing, I want to focus on is really how to start, how I got it started with this. And one of the powerful capabilities within Fusion is something called canvases. So you can insert a canvas, which is just a photograph, into Fusion 360. And as long as you take a photograph with something that the scale, I took a picture with obviously a ruler in it, but anything that the scale, works 100% fine, and you just tell it, pick point A and B, and this is the scale, and it scales the image to exactly that within the CAD system, and allows you to build around that. I mean, there's some restrictions, or I guess there's some limitations, I should say, that, for instance, the parallax that's within the camera, because there's a perspective of the camera, not everything is vertical. For instance, this panel is leaning away from the camera, even though technically it's vertical in this CAD. So you just have to know your plane of reference, and for instance, if my plane of reference is the top sill here, then where the panel meets the top sill would be accurate, but the rest of the profile would not be. So you just have to understand some of the limitations, but for the most part, you can take pictures fairly easy and put them in here, and you can see I modeled fairly well just the overall hull geometry that got me started. So this is the full assembly with the hull geometry. Let me pull the hull geometry out real quick just to show you the overall assembly. And it is really straightforward. It is just a 3-bar mechanism, and what you have here is the first bar being from the main pivot point to the panel, then from the panel down through the nitrogen spring, and then of course the main block here. Most of the load in this is managed by this block, and my concern was how strong it would be and how much force it would be under. I was trying to pick nitrogen springs that were not that heavy or didn't have that much capability, but because of the angles here, I really needed one that was between 20 and 30 pounds, and there's 2 of them, to be able to lift the panel up, and the panel's about 10 pounds. So what that means is there's a good 30 or more pounds when it's all the way down pushing through this main block that I was concerned about being able to handle it. These are carbon tubes that I bought on Amazon. The nitrogen spring I just got from McMaster-Carr, and in fact, this pivot point I got from McMaster-Carr. The bolts and stuff got all from McMaster-Carr, and all of these other pieces are designed within Fusion 360, and I 3D printed them. So it's just an amazing capability that we have today that when I was a young engineer that didn't even dream of having. So the process to get here was really just looking at, hey, how do I make sure that my geometry in here is right? And I'm building a main block, is what I call these things, that can attach inside of the aircraft strong enough and rigid enough that it won't move, and they'll be strong enough to handle the forces within it. And then, of course, having the panel being able to hold on to the mechanism by itself. So, these pieces, they're under a fair amount of strain, and I was concerned about what materials I'll be able to print it out of and how I would be able to print them, but managed to find a material that works fantastic. So really, if you saw my video number 1, I talked a lot about the panel itself, and I just pulled in the DXF file from that to give me a point of reference to start off with, and then I just modeled some basic blocks on the back side to represent the actual instruments that are coming back, so I know clearances and stuff like that, and make sure that I'm clear in all respects. And then the next piece was really just getting the basic geometry in, and 2 pieces were very difficult to design. This one is we call it the horn. It is angled in 2 different directions, and it gets bigger to give more purchase area against the panel. And I've been through probably 100 iterations tweaking those 2 angles just to get them just right. And they're critical when you look at it directly from the side, when you get this thing vertical, to grab it there, to make sure that the panel gets vertical and it's flat across there, So it is angled in two different dimensions. If you look at it, from the top, you can see there's about a 15-degree angle between these two. So I'm angled roughly 15 degrees that way. And then if you look at it from the side, there's an angle. This isn't 90 degrees. It's about a 5-degree angle between those two. So getting that angle, the compound angle, just right, took a lot of iterative design. Other than that, it was really just a huge amount of test and retest and retest, and printed some blocks, went out there, it didn't quite fit the way I wanted, etc. So I worked really hard to get this block design exactly what I needed it to be. Originally, I had this cross member, and this cross member is important because it keeps this bar here from rotating around its axis, because it's free here, and even though the panel holds it, there's a lot of force because this thing is coming at an angle and it makes it want to torque. So I had a straight bar across here and I was drilling through these sidebars, but I decided that I was not really as comfortable with that, and assembly wise it made it difficult, because once I got everything in there, to get those pieces in between these, because those were the last that I would put in, would be the hardest part. So I decided to do a straight 90 degree here and create this pivot point that allows adjustability. So as this goes forward or backwards, this angle can change, and depends on the geometry of the airplane versus the geometry that I have drawn, it allows some flexibility. So once I got it all in here and being able to model all of the joints and everything to where I can articulate it through its full range of motion, allowed me to make sure that, again, when the panel goes up in an eject situation, the canopy's gone, where the top plate's still there, it's cleared, I have no problems with cables, etc. Just being able to do that, take pictures, articulate it, took most of the time, took a lot of time, hundreds of hours just going through that. But once you get it in here and you can manipulate it fairly well, it's easy to iterate the design and go from there. So a sneak peek at the next video. I'm going to go more into the printing and the installation, but this is what it looks like when it's done. In case you didn't want to wait for that video, this is the installation. So you see the lifting mechanism there, and it pops up nice and easy. It is gorgeous. So hope to see you in the next video. Thank you.